The basic derivative rule for logarithm is the natural log of x prime is 1 over x. The chain rule variation of this is that the natural log of u prime is equal to 1 over u times u prime. If u is equal to x, then x prime is 1, and you get exactly this rule. The simplest example you can really do for this style problem is the natural log of a constant times x, and you want to take the derivative, this with respect to x. So it would be 1 over u times u prime, which is 3 over 3x is 1 over x. So notice in this problem that this is u, and this is 1 over u times u prime, which is exactly this rule right here. Slightly more complicated example, the natural log of x squared plus 2x prime. This is 1 over u times u prime, which is 1 over x squared plus 2x times 2x plus 2. Wrong. You have to include the parentheses like this. That's one of the most common errors that people make, is they forget to include the parentheses like this with the chain rule term. So in this problem, our u is this term right here. This is 1 over u prime, and this is the derivative of this term. Sometimes people will write this rule as u prime divided by u to save space. In doing that, then you won't run into this parenthesis issue, because your problem will look like x squared plus 2x prime divided by x squared plus 2x, and then you don't have to worry about these parentheses, and you go back to this right away, 2x plus 2 divided by x squared plus 2x. Let's deal with a more complicated example that would be appropriate for a homework or quiz level problem in a university calculus class. Y equals the natural log, the square root of x squared minus x, and we want to find y prime. So in this problem, we have not only the derivative of logarithm, but we also have to contend with a chain rule as part of the derivative. Y prime is 1 over u prime. In this case, our u is equal to the square root of x squared minus x. So this will be 1 over the square root of x squared minus x times the derivative of the square root of x squared minus x prime. So here, this whole term starts out as the u, and then this is u prime. So we have here 1 over the square root of x squared minus x times the derivative of this term, 1/2 x squared minus x to the minus 1/2, and then by the chain rule times the derivative of the inside function x squared minus x. This is then 1 over the square root of x squared minus x times 1 over 2 root x squared minus x. So that's taking this negative exponent to the denominator, and then we have to multiply by this term times 2x minus 1. Correct? No, incorrect. You must include these parentheses like this. That is, again, probably the most common error. The square root of x squared minus x prime is x squared minus x to the 1/2 prime, which is then 1/2 x squared minus x to the 1/2 minus 1, which is minus 1/2. And then the chain rule says this term which you leave alone, now take the derivative by chain rule. So that's x squared minus x prime. This derivative, 2x minus 1, so you have to multiply this term times this one, and that's this. We saw that if you have log base e of u, and you want to take the derivative, which is asking for the natural log of u prime, the derivative is 1 over u prime, or u prime over u. This one we call Euler's number. Euler, not Euler, Euler's number. And it's approximately 2.7. It's just a number. A very important number, and the base of one of the most important functions in all of mathematics, but nevertheless, it is just a number. If we want to calculate the derivative of log base b of u, then we have to apply the change of base formula for logarithm. So we'll say this is log base b of u is the natural log of u divided by the natural log of b. Then notice the natural log of b is just a number. So here you have the natural log of b is a constant in R. Here's an example. Suppose that y is equal to log base 10 of 2x squared minus x. Then we want y prime. So y prime will be the derivative of log base 10 of 2x squared minus x. But we can't differentiate this until we change the base, and then we can use this formula here. So we write this as the natural log of 2x squared minus x divided by the natural log of 10 prime. Notice in this formula that this u here is this term here, and the base b here, the base b here is 10 is 10. Now this is a constant, so we can pass it through the derivative. So this is 1 over the natural log of 10 times the natural log of 2x squared minus x, and now the derivative is only being applied to this term here. Notice what we're able to do is we basically take this constant and pass it through the derivative. This idea is the same as saying a constant c times a function of x, you're differentiating the whole thing, is equal to that constant times f prime of x, like this. So you're able to pass the constant through the parentheses. Now we differentiate this according to this rule. So this is 1 over the natural log of 10 times 1 over 2x squared minus x, 1 over u times u prime. So this is 4x minus 1. Wrong. You must have these parentheses.